And I say fun. I mean, I'm having fun. I hope you guys have fun in the process. Today is on two theorems and they almost kind of lead as a segue in chapter 5. But 4.8 is on Rolle's theorem. With an E at the end of the word roll. And the mean value theorem. Which is abbreviated MVT. It's used a lot. So what is Rolle's theorem? How does it work? We're gonna require. We're gonna say f of x is differentiable. On the open interval AB. And continuous. On the closed interval. If f of A equals 0 and FB equals 0. Then. Get you used to the notation now. A capital E backwards means there exists. Then there exists at least one point. X equals C. In AB. Such that C is in AB. This means in. Or element of. Depending on the notation, here it's in. Such that C is inside AB and f prime of C equals 0. Another way of looking at this thing is A is less than C is less than B. The words you're like, if you see a picture, you'll be like, no shit. So here's A, here's B. And we have some function. Whether it goes straight across, it could go straight across, it could go up and wiggle around and come back down. It could go down below, it could cross again, it could cross a few times and hit there. But at some point. Let me do a green line. There is some point C. Where f prime of C equals 0. Or if you do it above the line. Zero. Kind of like if it's 0 here. And 0 here. And it goes up, what goes up must eventually come back down. Now, we say that because of gravity, but like here, the requirement is that f of b equals 0, so we know it comes back down. Or over here, it goes back up if it went down first. Now, there is ways to draw a graph that doesn't have that. If we did some shit like this. There is no spot. F prime of C equals 0. But that's because if we call this C. F is not differentiable here. It's a cusp. And we showed with like absolute value and stuff that doesn't work. So like that graph has it, but it breaks the requirement that f of x has to be differentiable. That's why we include that. It's kind of a weird proof. We're gonna go over the proof. This is a little math jargony. As long as you get the premise of this, that's the important part. But I'm gonna show you the proof just so you've seen it. Everybody check a second to finish writing. Alright, so the proof. So we need to have our given information, given that. F is continuous. On AB. F is differentiable. On AB. And f of A equals f of B, which equals 0. The goal is to prove that there is a C such that f prime of C equals 0. Well, we are going to assume one thing. We'll start off by assume f of x does not equal 0 anywhere in AB. Well, the open interval AB. Because if it did, we're already done. F prime of x is 0 automatically. Derivative of a constant is 0. So we're going to assume it's not constant in it. Case 1. We will assume f of x is greater than 0 somewhere. Like it goes above it. At some point in AB. And since we've assumed f of x does not equal 0 anywhere in there. Then it kind of holds true. For all x in there. Because f of x does not equal 0 anywhere. And the only way to get down to a negative would be to cross the line. So it's positive there. And since we're looking at a closed region. There has to exist a max somewhere. On a closed interval. By the extreme value theorem. This was what we were doing with the absolute values and shit. Absolute max and stuff. There's a max. And it's not at one of the endpoints. Since they are 0. So if the max is at x equals c. Then. Ooh, darkness. C is a critical point. C being a critical point tells us two things. Either A. F prime of C equals 0, or B. It is, or f of x is not differentiable. Wow, this is an easier way to write it. F prime of C does not exist. That would be option B, like there's a cusp. But since f is differentiable. B is out. And f prime of C equals 0. Mathematics, if you go down pure mathematics, are a very big fan of proving shit with words only and without pictures. When the picture of it makes it clear as fucking day, it has to be the case that there's no other way for it to happen. So if you want to do fun shit like this, be a pure math major. I am not one of them. Doing proofs is not fun for me. But they serve a purpose. Case two. We are not gonna walk all the way through case two. Case two is f of x is less than 0. Same argument as case one. But replace max with min. Nothing else has changed. I got me one of those sleep masks. My doctor wants me to use the CPAP. It's fucking quiet. I always heard they were loud. Super fucking quiet, but I look like Bane.
Which one did you,
And I fucking hate it.
what did you get? Was it the,
It's a full like the full mask, cause they said
Covers your
it's-
nose too,
if
right?
you ever snore. It's easier on you, but like I fucking hate it. Cause you put it over your head and it's got like little Velcro snaps. And if the snap isn't so fucking tight to be like. Super like
basically
Bane,
it's-
literally Bane. When the pressure on the thing ramps up, the mask will try to push away from your face a little bit in sleep. And then you hear the wind blow to the side, it fucking wakes you up, or. It fucking fills my mouth and makes my mouth open up inside the mask and all of a sudden I'm like. I wake up in the middle of the night like that, and if I fucking tighten it down so much that it fucking makes it so my jaw can't move. Then it doesn't do it, but that is an awkward way to sleep. I fucking hate
is
it,
it the one that pushes up on your nose or it covers your nose
it
completely?
covers.
Okay,
There was three options, there was. Do this like literally like Bane. There was one where it's like the Rudolph nose and it just covers your nose. And then there's one where it's like being in a hospital and they like do little nose plugs like that. And that didn't sound comfortable and I don't know. I went with the one they recommended and I don't like it, I hate it.
my dad got one, where it covers his mouth, it's a triangle, but it covers his mouth, but then it just goes up to his nose, it doesn't cover it. So he basically just puts it on his nose and when he tightens it, it almost like locks onto his nose and then it covers his mouth still. It occasionally will fall off, but he's also a little bit of a restless sleeper sometimes, so.
How is it forcing air in if it's not going through
I think
the
it's more
nose?
his mouth because he's a mouth breather, so I think it's more for his mouth, but it supports by. Giving him air through his nose as well. So,
I don't like it, I have a doctor's appointment with the sleep doctor today, it's been a month, I'm gonna bitch. Alright, let's do some examples. Distract you guys with boring shit for a little bit. Well, at least one example. Let's verify Rolle's theorem. And find C. Where f of x. Equals 1/2 x. Minus the square root of x. On 0 to 4. So, A. We have to show it's continuous. Is it continuous?
no,
It is.
Oh.
1/2 x is. And square root of x is.
Oh.
And the sum of continuous functions is continuous. If it wasn't continuous, I can't verify shit on this.
I thought you meant.
Just poorly.
I don't know why I thought you were talking about the intervals, I was like, no, you're only going from 0 to 4.
So it is continuous, is it differentiable? This is an easy one to find out, take the derivative. F prime of x equals 1/2. Minus 1/2 x to the negative 1/2. And it needs to be differentiable on 0 to 4, not necessarily including 0. Or 4. The only problem spot for the derivative. Only problem is at 0, but that's not included. And finally, does f of 0 equal f of 4 equals 0? Plug them in. 1/2 times 0 minus the square root of 0 is 0. F of 4 is 1/2 times 4 minus square root of 4. 2 minus 2 is 0 also. Which means we met all the criteria. A, B, and C are met. There exists some C such that f prime of C equals 0. And let's find the C. We are going to do that, force this criteria. F prime of x, we already did it, was 1/2 minus. I'll write this like this. And we want to do f prime of c. Replaces all x's with c's. That needs to equal 0.
I don't know,
Back froze,
yeah,
like deer in headlights. I think this is a little easier to add this to the right side. And we will multiply through by 2 root c on both sides to clear fractions. And that means I get square root of c equals 1. Square both sides, and we get c equals 1. So we found the value, and 1 is in 0, 4, so that works.
say if we got something that wasn't in 0, 4, like we got like 5 or 6.
So you gotta exclude that one.
This
Cause
one,
we're literally, then you're looking outside the range, and we have no guarantee that any of that shit's true later on.
this only works for that close interval, so you have to find something in it, and if we don't, let's say, like you said, like 4 or like 5. When you mean exclude, do you mean we just don't have C at that point then, we just can't find it?
We should find to be able to find the C that's in it. What I mean is if you've got two answers and one of them was outside of it, exclude the answer outside of it. We might have answers where there's more than one C inside. It could do something like this. Where it wiggles like that and it's a couple points. But if the function does it again outside, we don't, like this point here, this point here, this point here, this point here. That point there, all the peaks and valleys have derivatives of 0. But we don't want any of the ones outside the region. As part of the Rolle's theorem. I mean, it could still be 0 there, that's nothing, there's nothing wrong with that, but like in terms of. You're only really using the rules, there's a reason to use it, and it's to find something in that range. If you're looking for values in that range kind of thing. So why look outside the range? You don't even need Rolle's theorem to find the zeros in the first place. Right? So there's a purpose for Rolle's theorem. And like this one isn't all that exciting, because you could have already shown that without having a theorem for it. But we're gonna use Rolle's theorem to prove the mean value theorem. And that's where the Rolle's theorem actually proves itself to be useful. Because was unessential. Do we really need to do this? Couldn't we have just taken the derivative and found where it was 0 all on its own and not needed the theorem? Yeah. The theorem just guaranteed that there was one inside there. Does that make sense? Okay. Which leads us to the mean value theorem. We will again require f of x to be differentiable on AB. And continuous on the closed AB. We are not restricting it where we require endpoints equal to 0. Those are the only requirements now. Then there exists at least one point C in AB such that f prime of C equals f of B minus f of A over B minus A. So this is slope of the tangent line. And this is the secant line through AB. Pictorially, it helps quite a bit. So same slope between these two. So that's f of x. Let's call this line here g of x. Use it for the proof. Before I get to the proof though, it's worth noticing that the Rolle's theorem is just a special case of this. MVT where f of a equals f of b equals 0. We do that, f prime of c becomes 0 because the top is 0. And we have the same stuff that has the Rolle's theorem. So let's talk about the motivation for this proof. There is a vertical height difference. Between f of x and g of x. Let's call this b of x. So b of x is measuring the vertical distance between these. And to do that, it's just simply f of x minus g of x. What's unique about this is at c. B of x is maximized. Or finds its maximum value.
Would having f of x, g of x, subtracting f from g, just give you the point you're looking for then?
No, it's giving us a function for the distance. Any distance, like if I do x equals, like right here, it's giving me this distance. If I do x equals over here, it's giving me this distance. And at c, it's giving me that distance. So we just need to find the equation for it and try to find the maximum value then. Need more paper. So we want to find a good equation for b of x. We have f of x, we don't have g of x. Okay. Yeah. We do know g of x is a line. through. X equals A. Well, A, shit. A, F of A. And B, F of B. Cause that's those, this is A and then the vertical height, we call it Y, but we find the Y by plugging it in. And up here is B, F of B. And if it's a line, we've got y minus y1 equals m times x minus x1. But m we can find doing the slope formula. Like y2 minus y1 over x2 minus x1. For this problem, that turns into f of b minus f of a over b minus a. So I'll plug that stuff in and I'm gonna use this as my point one. So if I plug that in, I have y minus y1 is y minus f of a. Equals. M, which is f of b minus f of a. Over b minus a, that's my m. And then I gotta do x minus x1, but x1 is a. If I solve for y, I have g of x. G of x equals y, and I can get that just by adding f of a to both sides. And now we have our f of x, we have our g of x, we can put them together. B of x is f of x minus g of x. Which is f of x minus. F of b minus f of a. Over b minus a. Times x minus a plus f of a.
I can just minusing an f of x on both sides as well, which then also means that we're solving for now f of, or b of x.
No. This is our b of x. That's b of x and we're gonna use this.
Yeah, okay.
So, what happens at b of a and b of b? We look at b of a. I'm just replacing x's with a's. I have f of a minus. F of b minus f of a over b minus a. Times a minus a. Plus. Oh, I subtracted it, which, shit, I subtracted it and I didn't apply that subtraction there. Sorry. We're subtracting g of x, so everything in this has to be negative. That's what was wrong. I'm like, this isn't gonna work. I didn't distribute, I was sloppy. And this is 0, so that's 0. And we get f of a minus f of a is 0. So v of a equals 0. What about v of b? We have f of b minus f of b minus f of a over b minus a. Replacing x with b, so b minus a there, minus f of a. And you'll see if we clean this up, this b minus a cancels this b minus a. And we have v at b equals f of b minus f of b on top. Distribute plus f of a. And then minus f of a. This is actually 0 also. Which makes sense if we look at the picture. The vertical height between these two things at the endpoint should be 0. They touch, they cross, that's how we made the function. So pictorially, that makes sense. So this meets the criteria for the Rolle's theorem. Which means v of x has a max inside at c. And b prime of c has to equal 0. And but b prime of c is what? We have f of c minus f of b minus f of a over b minus a times c minus a minus f of a. So I'm gonna add this term to the left. Because it's 0, I can add it to both sides. I've got f of b minus f of a over b minus a equals, or times c minus a. Equals. F of c minus f of a. And if we divide by c minus a. We get f prime of c over here. So F prime of C equals F of B minus F of A. Minus A.
Jones, what'd you say you did with this stuff? The F of B minus F A over B minus A? You,
So I just added this term to over to the zero, added it to both sides.
okay,
It clears on this side, it's over here. And we're just left with F of C minus F of A. And then, maybe I'll do this in red. Then I divided both sides by C minus A.
oh, gotcha, okay.
We'll do some applications or problems with it, let's see if I can remember. Alright, welcome back. Megan during the break pointed out that I was being a fucking idiot. She said it much nicer than that. She asked why we weren't just taking the derivative. And that's the correct way of doing it. I'm stuck in. I had a brain fart, misreading my notes, didn't know what the hell I was doing. If we had B, this was our V of X. If you just take the derivative with respect to X. This is a derivative. This is just some value, this is a constant. This is a coefficient. So we're taking the derivative of X minus A, which is just 1.
Wait, so. If V prime of C equals 0 equals F of C, is that the,
We're getting there a better way.
okay,
This is a better way. This is the way I was supposed to do it. The other way required doing a limit that I didn't have in there. So just take the derivative. d dx on this bad boy. That gets you b prime of x. That turns into f prime of x. A is a constant, so derivative of x minus a is just 1. Derivative of x is 1. Derivative of f of a is 0, and x had this coefficient on it, like if we had 2x and we took the derivative. We just have 2. Same idea here, but the 2 is f of b minus f of a. Or b minus a, same as the 2 here. So that comes down, and now that is v prime of x. When you apply Rolle's theorem. Then there's some point C inside where that derivative equals 0. And then you're solving for f prime of C. For Anthony, I got to go to the whole math road, but I did astrophysics for graduate work. Rather than doing lame ass proofs, I got to do some like astrophysics, that's some cool shit. And anything that was super hard, we just made the computer do. Not AI, you actually program out, if you go applied math, you'll see there's a lot of. If you like computers, there's a lot of computer programming in it. Because eventually you can't solve some of this shit by hand. All the problems we have in here, like in the textbook and shit, they're tailored to give you nice, clean answers. Clean is kind of, even if it's some fucked up decimal, it's still an answer. There's a lot of things you just can't take the derivative of or integrate, as we'll do in chapter 5, but computers can do it. And that's what upper division stuff goes for. Alright, so let's put this shit to work. Wait. Sorry, you're still writing. It was really, I had a class on star formation and shit like that. It was really cool. I think my favorite class is fluid dynamics, though.
Which worked or?
How fluid, the mathematics behind fluids. Yeah, a lot of things count as fluids, not just liquid, but like plasma or gases move like a fluid as well. And if you study fluid dynamics, you learn how shit flies, how we make airplanes fly. That's the math behind flight, that's fucking cool. Alright. Everybody looks like we're done writing, let's do some examples. Let f of x equal. X cubed minus x squared plus 1. On, let's go -1 to 2. And let's find all numbers. Or all values C. That satisfy. The MVT. Step 1. Unless it's stated that the conditions hold. You have to show them. I believe I had on the, I think I have on the group practice test. Just assume these conditions hold, that way you can get straight into the MVT. But we have to show A, it's continuous. Well, f of x is a polynomial and polynomials are continuous. So that's met. The derivative exists everywhere, it's differentiable. F prime of x equals 3x squared minus 2x. We were able to find derivative, and there's no problem points inside of -1 to 2, so. Good. And those were the only two conditions for the mean value theorem. The Rolle's theorem had f of a equal to f of b equals 0, but this one does. So we're gonna do f prime of c, this is our mean value theorem, we just gotta plug in the shit that works. That's MVT, we're using, that's our derivative, that's f prime of x. A is our left endpoint and B is our right endpoint. So if I set this up, if I plug in C. I get f prime of c equals 3c squared minus 2c. And that needs to equal f of 2 minus f of -1 over 2 minus -1.
Where did you get the a equals -1 value?
Okay. Alright.
Was it in Q?
I don't know if that shows the negative very well, it looks kind of like part of the bracket. Sounds like cornets. They're the loudest fucking crunching thing on the planet. It's incredible how loud they are.
I was trying to be discreet, but
There's no discreetness with cornets.
Cornets are so good.
I know it's not,
They're pretty good.
it's really like crackers.
Sound like cornets. Alright, so, well, we need f of 2 and f of 1, or -1. Maybe we'll just do this as a little sidebar here, we're plugging in up here. 2 cubes minus 2 squared plus 1. We have 8 minus 4 plus 1, looks like 5. So that'll be a 5 right there. And then f of -1 is -1 cubed minus -1 squared plus 1. This is -1 minus +1 plus 1. Looks like -1. So that'll be -1. So this is 5 minus -1 over 2 minus -1. 6 over 3 is 2. And that equals that. So 3c squared minus 2c equals 2. And this looks quadratic, so we'll move the 2 over. And that doesn't look factorable, does it? So. Quadratic formula. C equals, let's see. I hate using C because we tend to use A, B, and C in the description of the quadratic formula. We have the negative of that, so +2 plus or minus the square root of that squared minus 4 times 3 times -2 all over 2 times 3. So what do we have in there? Inside, we've got 4 plus 24 equals 28 on the inside. So C equals 2 plus or minus square root of 28 over 6. And we'll get two different values. Pump C1. If we do the plus. 2 plus square root of 28 equals divided by 6. Approximately 1.2. And C2 is the negative version. 2 minus square root of 28 divided by 6. Approximately -0.5. It will go 2 decimal places 5 times. And we want to make sure, are these in -1 to 2? Yes, so both answers work. Both C answers work. C equals 2 plus square root of 28 over 6. That's C1. And C2 is 2 minus square root of 28 over 6. For the exact answers.
what didn't work, we just exclude it.
Do you wanna try one?
Sure.
I wanna do this.
Do you have a polynomial?
What?
Do you have a standard polynomial? That's
I think it's a polynomial. Make it so it's not a polynomial. Can I do that here? Will that work? Continuous differential. 3 sine 2x. Let's go on 0 to 2 pi. Oh, those are gonna have the same value, like this is just basically Rolle's term, let's change this up, make this. 5 pi over 2. 0 to 5 pi over 2. I'll leave that out as stuff you gotta do on your own to show.
So on the one you labeled one, that unless it's stated that the conditions for MVT hold, you have to show them, is that, what were you meaning by that again?
You have to show that it's continuous and differentiable, or
Oh, gotcha,
justify that it's continuous and
Okay.
differentiable. Is a sine function continuous?
Yeah,
Yes.
Okay.
Can you take the derivative and have any problems here? Yes.
Yeah. Can we take it and have problems?
Or not have problems.
Okay, I was gonna say.
I think I said that, yeah, I think you're right, I said that wrong. This, you can see more of that. And then I'll put on 0 to 5 pi over 2 under it. So you can see it all on one screen. While you're working through it. You could hand at it and then we'll do it together. Oh.
So double
It's
sine,
not even another constant.
but the left side's already. The left side's already.
You know, took it out.
Jones, if we have negative sign, we took rid of that's negative cosine, right? That's
Yeah.
it, okay,
Derivative of sine is cosine, derivative of cosine is negative sine.
so yeah, I guess if you took a triple derivative, then it would be like negative cosine, but don't freak out. Don't do that.
No idea how hard this is, I just made this shit up.
Not too bad, as
Shouldn't be too bad.
long as you don't take the road, right?
I'll go over in a second, just try to work on your own without letting. Gain something from this and we'll go over it together, I'm just verifying that we can do this fairly easy. Ah. Still rolls through, fucking still made it easy. Son of a bitch. I needed like a pi over 3 or some shit, since the twos didn't cancel. That's still 0, isn't it?
Jokes, are we not plugging in A or the A and B like we did in the last one? Into the original equation?
Yeah, we are,
Oh, we do?
yeah.
Okay.
But then it's
Oh.
0 minus 0 over, who cares? Not 0, it actually does matter. 0 minus 0 over not 0.
Yeah,
If you have 0 over 0, now you got Loki golf. Oh yeah, this was easy to.
Huh?
This actually is an optimal choice. Cause this is gonna have a whole lot of fucking things that meet the criteria. But we want to eliminate almost all of them. So I need to write this down, now. This is a great job.
realistically looking like that other stuff. A and B. X. C. So it's basically just replacing. You're just replacing A and B in X. Yeah.
So,
It would have. You want to. Be. See. This is your.
Well, this is how well do you remember your trig at this point, right?
Six. Basically that,
put it into the.
it's the derivative one. Oh, no, sorry. Shit, you're right. Sorry. I was looking over You're right, it is the first. one.
Yeah, which is just a specialized version of mean value theorem.
Which is just,
They both,
If that means zero.
both technically apply.
Because A
But
is zero.
the means value theorem kind of
And
turns
you
into
put
Rolle's
that
theorem.
there, so.
But either way, there is a derivative somewhere inside that. Matches our f prime of c. Which happens to be 0. Right. Walking through it a little bit, if you take the derivative, you've got 6 cosine of 2x. Don't forget the chain rule by taking the derivative of the inside. And then, so we plug in c, f prime of c, we have 6 cosine of 2c equals. The function evaluated at 5 pi over 2 minus 5, or evaluated at 0, but that is sine of 5 pi. minus sine of 0, and both of those are 0. The bottom is not 0, so we're 0 over 5 pi over 2, which is 0. So we can solve this by saying, well, divide by 6. Cosine of 2c equals 0 still. This step might be a little bit easier if we say theta equals 2c for now. And just figure out what thetas apply here. So what theta, which is gonna equal my 2c, what values of theta give me a cosine of 0? Pi over 2. 3 pi over 2. 5 pi over 2. Basically, every pi, this is pi over 2 plus n pi, right? This multiples of pi. 2c equals pi over 2 plus n pi. We didn't start with theta, so we don't want to end with theta. So we're gonna use 2c. And we want c, so we're gonna divide by 2 or multiply by 1/2. So we get c equals pi over 4 plus n times pi over 2. This gives us a lot of numbers. Pi over 4 works. If I add. This is effectively like n times 2 pi over 4. So I can add 3 pi, add 2 pi over 4, keep adding this. It goes the other way. There's a lot of values. We want the ones. We want C in 0 to 5 pi over 2. And this might be easier to do if I multiply this by 2 over 2. I want 0 to 10 pi over 4. Which looks like we're looking for these answers right here. C equals pi over 4. 3 pi over 4. 5 pi over 4. 7 pi over 4. And 9 pi over 4. All the other values are excluded because they're outside the range we're looking at. So this is an example of where you don't want all C's. And that refresh some trig, you probably haven't how to deal with finding it when it's not just a theta or an x inside.
Did you mention about the one?
Next semester, do you guys have a plan for the students that are coming in without knowing trig?
That's on next semester, it's gonna be fall. Professor Beret and I are working on doing a flipped class model where they watch little lecture videos at home with a lesson plan. And then class time is all activities, working with each other. We're presumably, I don't think it's gonna be in this room, but the whatever room it is over here. Have whiteboards on the walls, so there's gonna be a lot. We're trying. We've got a plan, we don't know how well it's gonna work. But we're doing the best we can with what the state's mandating that we have to do.
So, I mean, I talked to my counselor about why they decided so why they decided about this. So the thing is that it sounds like there wasn't any mathematicians at all involved in this whole process, right?
So there's a college down in like Southern California that did a run of this and had students do successful. And then politicians are like, well, fuck you all have to do this now. And made it law. And the idea is like, if you're going to go into a system. AB 705 was you have to be able to be put into a transferable math course right away. For non-STEM majors, that's like stats or something. They're like, we want that to apply to STEM majors too. And the first class that transfers is calculus. So you have to be put directly into calculus. And who gives a shit whether you had the pre-existing skills before then. They're willing to allow us a support course to do it. The chancellor's office, which is for the entire state. In their infinite douchebaggery wisdom, said it can't be more than 2 units of support for the course. The law doesn't say anything about that, but the chancellor said that. So effectively, we get like a 2-unit support course, which is 2 hours, which is normally like 2 hours a week to try to fill in all your algebra and trig gaps. We managed to write it as 1 lecture, 1 lab, and the lab hour is 3 like in-person hours. So we're gonna get 4 hours a week. And we're just gonna do like whatever you need right before we're doing it. Like when we did limits, there was a lot of factoring and canceling and doing shit. So we're gonna go over factoring and exponents right before we go over limits. We're gonna see how it works. We're hoping by making them watch it at home and then doing just activity after activity, working together. Which is the point of the group exams, working together tends to help. We're hoping that helps. I don't think we're gonna have the same pass rates that we normally do, but hopefully it's higher than the 15% that the fucking state thinks is acceptable. You don't like it? Hire fucking vote for new politicians next time. Now that you're all getting to voting age. Alright. So. Fun thought problem. If a car travels 180 miles in 2 hours. Is there a point during the drive? Or a moment during the drive? Where the speedometer reads 90 miles an hour. So. The 90 mph is instantaneous velocity.
But we're assuming that there's no stops at all during this.
Nope, I did not make any assumption like that.
You stop and you still make it. So
Yeah, the only assumption is that they drove for the full 2 hours. So they're continuously driving. Even if that meant the speed is at 0 because of like a stoplight or something. 90 miles per hour is instantaneous velocity. Or instantaneous speed. I can find the average speed of the drive. Is 180 over 2, right? Which is 90 miles per hour. Also. So does that mean it had to be 90 miles per hour somewhere during the drive? Why?
I mean, if the average is 90 miles per hour, but
you
because at some point you had to pass 90 even if you went over. Cause if you're averaging, that means that between under and over, you had to be over at some point.
Fair enough. So there's a couple cases here. Case one is we were 90 miles per hour the whole way, never lifted, like the foot was on cruise control, it was on cruise control. The whole way, and this obviously works. Case two. At some point, we were less than. Which means to average. But to average 90 miles per hour. Means we had to go over it at some point. We went over 90. Which means it crossed at 90. And case three is the other way. Just saying we started at above, like we were gunning it at 120, eventually we had to like slow down. Case three is. We were higher and then had to go lower. If we think about it in terms of Rolle's theorem. Not Rolle's, mean value. This is instantaneous velocity, or speed. And that's average speed. So there is a C. Inside. Where. F prime of C was 90. Just by filling in these two values. That's like starting at 0 and being 100 miles, 180 miles away. Well, that's the F. This would be 180 minus 0 over 2 minus 0. Distance over time. That gets you your 90, so we get an F prime of C is 90 somewhere. That's an application something you think about, or you're not even doing math. Feel like it totally makes sense. We're gonna go over two little tiny theorems that you're gonna think. Well, I hope you think the first one's kind of stupid. The second one is actually gonna turn out to be really useful when we start doing chapter 5. The first theorem is gonna be. The name. If f prime of x equals 0. For all x in AB. The symbol for all is an upside down capital A. That's fun. Then f of x is constant. On AB. The proof of this is relatively simple. Let's pick 2 points. X1 and X2. Inside AB. Well, not inside AB, let's just pick 2 points on f of x. And we'll make those our endpoints. So x1 to x2 is our endpoints. And we will apply means value, or apply the MVT. F prime of C equals f of B minus f of A over B minus A. Which in this case is f of x2 minus f of x1 over x2 minus x1. The criteria was f prime of x equals 0 for all x, which means that applies for this as well. So this equals 0. Since x2 and x1 are different points, we can clear fractions. And we get f of x2 minus f of x1 equals 0. And therefore f of x1 equals f of x2. Just add f of x1 to both sides. But we didn't choose. We didn't pick values for x1 or x2, so anywhere. So any x value works. And the only way this works. Is if f of x equals k constant. Any other value of x is gonna change the value. A line has different values of output. Curve has different values of f anywhere on the curve. The only one that doesn't is a horizontal line. Not the most exciting one. The next one kind of stems from it though, and we're gonna use it. Not today. It's not on your test, but. Like, it's worth putting in your head now. This is a corollary to the last one. If f prime of x equals g prime of x. For all x in AB. Then f minus g is constant. On AB. In other words, f minus g equals some value k. Which implies. F of x equals g of x plus some constant.
So they were point slope.
Hmm.
GX plus K is just.
It means one is a shifted version of the other, one is elevated above the other. Notice if I subtracted. If I did this, subtracted g of x from both sides. G prime of X from both sides, I have that. And now we are in the. In the previous theorem. This is like, maybe we call this H prime of X equals 0. Or F prime of X minus G prime of X equals H prime of X. Let's say F of X equals sine squared X. And G of X equals -1/2 cosine 2x. Find F prime and G prime. I'm gonna let you do that real quick. Should be quick derivatives. Should have a negative there. So what's the derivative of F of X? It's 2 sine X cosine X. And what's the derivative of G prime?
Just sine 2x.
It's just sine 2x, right? But sine of 2x is 2 sine X cosine X. And by the last corollary. This means. Sine squared X has to equal -1/2 cosine 2x plus some constant K. And you're like, how could that possibly fucking be? The math plays out. And I've got both drafts loaded on Desmos, so you can see for yourself. The red line is sine squared X, the blue line is -1/2 cosine 2x, this just one is moved up. We could probably find the value for it too. We could subtract them. Let's do sine squared X. Minus -1/2 cosine of 2x. And what is the value of this line? The y value is 1/2. So that constant is, the k is 1/2.
Is that the 1/2 before the cosine?
This is the subtracting the two. And we get our constant, the f of x minus g of x. This has got to be the k is 1/2 the y value. So they're off by 1/2. All right, that's it for today. We will have a practice test on Thursday.